Today's episode is actually a special request from a viewer named Arjun, who reached out asking for a super simple, useful guide on how electric glass top stoves actually work and the absolute best way to use them. They look amazing. They wipe clean like a dream. But the marketing around them is an absolute mess. You go to buy one, and the box says things like infrared cooktop, halogen, radiant, or my personal favorite, the completely scientifically impossible phrase, any vessel induction. If you are confused, you are not alone. So today, for Arjun and everyone else trying to figure this out, we are going to peel back that black glass. We are going to cover how they work, the hilarious marketing lies, the absolute best and worst utensils to use, the golden rules for cooking on them, and the hidden costs of upgrading to newer technologies. Alright, let's get into it. First off, what actually is an electric glass top stove? At its core, a glass top stove is just a modern, highly engineered version of a traditional electric coil stove. When you hear the terms infrared stove or radiant cooktop, they are talking about the exact same thing. Unlike a gas stove that uses an open flame or an induction stove that uses magnetic fields, an infrared stove relies on brute force radiant heat. If you could lift up that black glass surface, you would see a circular track housing a heating element. When you turn the dial, electricity rushes into that element, and because it resists the electrical flow, it generates massive amounts of friction at an atomic level. It gets so incredibly hot that it starts emitting intense infrared radiation, glowing a fierce, bright red. That infrared energy blasts straight up. But the real magic is the glass itself. It isn't normal window glass, it is a highly specialized ceramic glass blend. This material is designed to let infrared heat pass straight up through it, while preventing the heat from traveling sideways. So, the glass directly above the glowing coil gets scorching hot and physically transfers that heat right into the bottom of your frying pan, while the glass just a few inches away stays relatively cool. Now, not all infrared stoves are created equal. If you look closely at the market, you will find there are two completely different technologies creating that red glow underneath the glass, Nichrome and Halogen. Let's talk about Nichrome first. Nichrome is an alloy of nickel and chromium, and it is the undisputed workhorse of the appliance world. Inside the stove, it looks like a thick, corrugated metal ribbon or wire. When you turn it on, it takes about 10 to 15 seconds to heat up, slowly blooming into a deep, steady red glow. It is incredibly cheap to manufacture, incredibly durable, and will easily outlive the rest of the stove. The downside? It is a bit slow. It takes time to heat up, and because that thick metal holds onto heat like a sponge, it takes a long time to cool down. Then, you have halogen. This was the industry's attempt to make an electric stove behave like a fast, responsive gas flame. Instead of a thick metal ribbon, a halogen stove uses a quartz glass tube filled with halogen gas and an incredibly thin tungsten filament. It is exactly the same technology as a high-powered spotlight. When you turn a halogen burner on, there is zero wait time. It instantly emits a blinding, blazing white-orange light and blasts maximum heat from the very first millisecond. It boils water incredibly fast. But because it is essentially a highly stressed light bulb, it is more expensive to buy, and the bulbs eventually burn out and need replacing. So, Nichrome is for the budget-conscious cook who wants a stove that lasts forever, and halogen is for the impatient cook who wants their water boiling 5 minutes ago. But regardless of which element is under the glass, you are going to run into the most frustrating marketing trick in the appliance world, the any vessel induction. Lie. Induction cooktops have become incredibly popular because they are hyper-efficient, but induction requires special, expensive magnetic cookware. So, what did the marketing departments do? They took standard infrared stoves, which do not use magnets at all, and slapped the phrase any vessel induction on the box. Let me be perfectly clear. That is scientifically impossible. It is an oxymoron. If a stove works with a clay pot, an aluminum pan, or a copper vessel, it is absolutely not an induction stove. It is an infrared stove. And that brings us to the biggest catch of all. The box proudly claims it works with any vessel. And technically, infrared heat does not care what material your pot is made of, but it cares deeply and ruthlessly about the shape of your pot. Because infrared relies on direct, physical surface-to-surface contact to transfer heat, you must use perfectly flat-bottomed cookware. Imagine you take a traditional, round-bottomed Indian kadai and place it on that flat ceramic glass. That round pan is only going to touch the glass at one tiny, dime-sized dot right in the center. The stove is going to pump 2,000 watts of blistering heat into that one tiny dot. The spices in the center of the pan will instantly burn to ash, while the food on the curved sides will stay completely raw. Plus, all the heat emitting from the rest of that glowing red circle will just escape into the air, turning your kitchen into a sauna and wasting a ridiculous amount of electricity. But what if you think your pans are flat? Well, you might be in for a surprise. This is where the infamous wobble effect comes in. To the naked eye, your favorite everyday frying pan might look perfectly flat. But over the years, as you have taken that blazing hot pan off a stove and washed it in the sink, the extreme thermal shock causes the metal to slowly warp and bow. On a standard gas stove with metal grates, you never notice it. But the second you place a warped pan on perfectly flat ceramic glass, it will spin and wobble like a top every time you try to stir your food. Before you buy a glass top stove, I highly recommend doing the ruler test. Take a standard straight ruler and hold the edge across the bottom of your favorite pots and pans. If the ruler rocks back and forth, or if you can see light peeking through the middle, your pan is warped. It will not work properly on a glass stove. But wait, having a flat bottom is only half the battle. The actual material your pot is made of can either make cooking a dream or completely ruin your expensive new stove. So let's break down the most common kitchen utensils into 3 tiers for an infrared stove. First, we have the top tier. This is your heavy-bottom stainless steel and your hard anodized aluminum. These are the absolute gold standard. The metal is incredibly smooth, so it will never scratch the glass. They conduct heat brilliantly, and because they are sturdy, they resist that dreaded warping effect we just talked about. Next is the middle tier, which is usable but risky. This includes raw aluminum, indalium, and enameled cast iron. Raw aluminum and indalium are fantastic heat conductors, but they are very soft metals. If you slide an indalium kadai across the glass, it can actually leave faint, silvery metallic streaks behind that are ridiculously hard to polish off. Enameled cast iron works beautifully for retaining heat, but it is incredibly heavy. If it slips out of your hand, you run a huge risk of cracking the glass top. And finally, the bottom tier. Avoid these completely. Bare cast iron, like your favorite seasoned dosa tawa, might feel flat, but at a microscopic level, it acts exactly like coarse sandpaper. Dragging it even a quarter of an inch will permanently scratch the ceramic glass. Traditional unglazed clay pots are an absolute nightmare on these stoves. Not only do they scratch the glass, but clay is a natural insulator. It actively fights against heat transfer, meaning you waste a ton of electricity just trying to get the pot warm. Plus, the intense, direct heat of the burner can cause the clay to crack from thermal shock. And lastly, copper-bottomed pans. If the stove gets too hot, pure copper can actually melt slightly and leave permanent, baked-on metallic stains fused into the glass. So, choose your weapons wisely. So, you have the right flat-bottomed stainless steel pan. What is the absolute best way to actually use this stove day to day? Here are the 3 golden rules of glass-top cooking. Rule number 1, match the ring or waste the energy. Underneath that glass, the heating coils are sized to match the white rings printed on top. If you put a small 6-inch pan on a massive 9-inch burner, you are going to blast 3 inches of raw infrared heat straight up into the air around the pan. It will make your kitchen sweltering hot, waste electricity, and can actually damage the handle of your pan. Always match the pan size to the burner size. Rule number 2, the lift-in-place maneuver. Never ever slide your pans across the glass. Even if you are using a perfectly smooth stainless steel pot, a single grain of coarse salt or a tiny piece of grit trapped underneath will act like a diamond drill bit. If you drag the pan, it will carve a permanent white scratch right across your beautiful black stove. Always lift the pan straight up, move it, and set it straight down. Rule number 3, hack the thermal lag. We know these stoves take a long time to cool down. Instead of letting that annoy you, use it to your advantage. If you are boiling pasta or simmering a curry that takes 20 minutes, turn the stove completely off at the 15-minute mark. That thick nichrome coil and the ceramic glass will stay hot enough to easily finish cooking your food for the last 5 minutes using 0 electricity. It is the smartest way to lower your power bill. Now, even if you follow those rules perfectly, there are still a few practical quirks that catch people off guard. Now, let's talk about the practical quirks. What are the unexpected surprises that catch people off guard once they finally bring an infrared stove home? Quirk number 1 is the disappearing red glow. I cannot tell you how many people buy an infrared stove, turn it on to boil water, and then panic because the bright red heating element keeps shutting off every 30 seconds. They think the stove is broken. It is actually a safety feature. There is a thermal limiter built into the stove to prevent the glass from melting or shattering. Once the glass reaches its maximum safe temperature, the element cuts the power. The glow disappears, and the stove relies on the residual heat trapped in the glass. When the temperature drops slightly, the element clicks back on. It is totally normal, but highly confusing the first time you see it. Quirk number 2 is severe thermal lag. With a gas flame, if your pot of milk is about to boil over, you just flick your wrist, turn the dial down, and the heat stops instantly. If you try that on an infrared stove, you will have a huge mess to clean up. Even if you turn the dial to 0, that thick nichrome coil and the ceramic glass stay blazing hot for a long time. If something is boiling over, turning the knob won't save you. You have to physically lift the heavy pot straight up and move it to a cold burner. And speaking of messes, quirk number 3 is the dreaded baked-on spill. Because the glass itself gets incredibly hot, any food, oil, or liquid that splashes onto the burner instantly scorches and bakes into a rock-hard crust. You cannot just wipe it away with a damp sponge. You usually have to wait for the stove to cool entirely, then carefully scrape the crust off using a flat razor blade at a 45-degree angle, followed by scrubbing with a specialized ceramic polishing cream. But the absolute worst-case scenario? Sugar pitting. If you spill a sugary liquid, like a sweet cup of tea or a boiling sugar syrup, onto a hot infrared burner, you have to clean it immediately. If melted sugar is allowed to sit and cool on the glass, it actually forms a chemical bond with the ceramic. As the sugar cools and shrinks, it is so strong that it will literally tear tiny divots and chunks out of the glass surface. It will permanently ruin your stovetop. And finally, you have to respect the weight limit. Ceramic glass is incredibly tough against heat, but it is still glass. It is brittle. Most single burners have a weight limit of around 15 to 20 kilograms. If you fill a massive, heavy commercial handy to the brim with water and meat, you might crack the glass. Worse, if a heavy pot slips from your hands and drops even 1 inch onto the stove, the concentrated impact will shatter the surface. And if the glass cracks, the stove is dead. Liquid can seep through the crack directly onto the live electrical coils, creating a massive fire and electrocution hazard. So, with all these quirks, why are people abandoning infrared and moving to induction? Well, induction changed the game by eliminating the heating element entirely. By using magnetic coils to generate a high-frequency magnetic field, an induction stove induces electrical currents directly inside the metal of the pan itself. The pan becomes the heater. This means induction boils water insanely fast. It means the glass surface stays mostly cool, so spills never bake on. And it means you get that instant, gas-like temperature control, because the second you turn the power down, the magnetic field stops, and the pan immediately stops generating heat. Induction is safer, faster, and more energy efficient. And over the last few years, the price of portable induction stoves has plummeted. You can pick one up for the exact same price as a basic infrared stove, but there is a catch. The massive, hidden tax of induction cooking. Remember how I said induction turns the metal of the pan into the heater? That only works if the pan is magnetic. If you are someone who loves cooking with traditional clay pots, heavy soapstone, classic aluminum steamers, or pure copper pans, induction will simply refuse to turn on. Even your expensive, high-end culinary stainless steel might not work, because the highest quality stainless steel has so much nickel in it that it is completely non-magnetic. So, while the induction stove itself might seem cheap, if you want to become a full-time induction cook, you have to upgrade your entire kitchen arsenal. You have to go out and buy a full set of heavy-duty, induction-compatible pots and pans featuring encapsulated magnetic bases. That complete cookware overhaul can easily cost 3 or 4 times the price of the stove itself. So, here's the final verdict. If you want incredible speed, perfect temperature control, and a stove that is a breeze to clean, and you don't mind spending a small fortune to replace all your pots and pans, go with induction. But if you want a reliable workhorse that will happily cook with your flat-bottomed, hard anodized kadai, your heavy stainless steel pots, and gives you that traditional radiating heat, an infrared glass top stove is the way to go. Just remember to lift your pots instead of sliding them, get a razor blade for the spills, and whatever you do, don't drop a heavy handy on the glass. I hope this clears up the confusion and helps you make the right choice for your kitchen. If you found this breakdown helpful, make sure to hit that like button and drop your appliance questions in the comments below, because you know I read them all. This is Sal, signing off. Happy cooking, and I will see you in the next one.